All right, so as you read in your textbook, there's it says right here in the green box on page 330, hey, up here. It says right here in the green box that y, if y equals log base b of x. Oops, I wrote down the wrong thing. Log base b, what am I doing? All right, got the coffee isn't kicked in yet. That is the same as b to the y of or equal to x. I am not awake yet. God bless you. All right, so that's the mathematical relationship. This is why we have, that's that relationship between logs and exponentials. Okay, so a log is like an exponential, we just write it differently. They're really kind of inverses of one another. And because they're inverses of one another, the x's and y's are kind of switched around, okay? And so if I'm given a log rhythmic function, I can switch it to an exponential function. And if I'm given an exponential function, I can switch it to a log function. Okay? And so let's do some of the examples. Does everybody have this written down? All right, good. So if I say log base 2 of 8, right? And I probably should have left that written down, but let's write it down over here on the side, okay? We said that y is equal to log base b of x, and then another way to write that is b to the y is equal to x. So now if I were to ask you guys, hey, what's this? What's this equal? Well, we just need to write it in the formula that we just need to switch it to the exponential. Now, I know that if you're reading your book, you see that the answer is 3, but here's where it comes from. If I wanted to write this down in terms of b to the y equals x, well, that would be 2 to the y equals 8. So what would y be? It'd be 3, right? Okay? Does that make sense? All right, let's do another one. Can we do another one? Okay. So the next example, and they just give you the answers, but I'll show you. If I were to say log base 3 square root of 3, remembering that the log base b of x is equal to y, then b to the y is equal to x. I have a base 3 raised to some y that equals the square root of 3. What's y equal to? This is a special case. Who remembers that? Yes? To the 1/2. Remember, when we take the square root of something, it's the same as raising it to the 1/2, right? So then this equals 1/2, which means that equals 1/2. Does that make sense? Let's do another one. You guys have this all written down? I'll wait a second. Well, that's pretty much about 25% of your homework right there. Because your homework is going to be, they'll either give you this and expect you to write it in this way, or they'll give you this and expect you to write it in this way. Well, they actually just want the answer. But I'm telling you, this is how you get the answer. Okay? Can we move on to the next one? Okay. The next one would be if I do, how about I do it backwards? No? Not yet? Okay, we'll keep going the regular way first. Look, I looked and I said, how about I do it backwards? And they were like, no, the whole back row was like, no. All right, here we go. If I say log base 5 of 1 over 25, this is a little challenging, but not really. When I write it a certain way, it'll make sense. So we're saying that y is equal to log base b of x, and then we said that b to the y should equal x, right? That's the relationship. Well, b is 5. That's pretty easy. So I've got 5 to some power equals 1 over 25. Now, I know the answer, and if you've read the textbook, you know the answer, but I'm going to ask you a question, and I want you to think about the question I'm asking you, okay? If the base is 5, and you look at 1 over 25, what should jump out to you? What do you think? What do you think the relationship between 5 and 25 is? Well, square, right? So I don't know why. Even Mr. Adams will say square root when I mean square. And
well, square root of 25 is 5.
Oh yeah, okay. If you think in that way, that's fine. But what basically, if you take 5 and you raise it, if you square it, it's 25, right?
Yes.
But this is 1 over 25. So what about if we think of it in terms of like 1 over 5 squared? So we're almost there. Can I write that in a way that it's 5 raised to the power? Okay. What about, could I say it like this?
Yes, I like that.
Does that mean the same thing? Right? Now, normally what you learn in algebra and algebra 2 is that if you have a negative exponent, you can make a positive by putting it on the bottom. And that's pretty much the only thing you did in those classes. But now in this case, it would be well, it's not the only thing, but it would be beneficial to you guys to know that property and move that up to the top, right? In other words, what I'm saying is that you can do that. Well, then what would y be? What's y? Negative 2. Very good. Now, that one's a little more challenging. I'll give you a second to write that down and kind of soak it in. Does anybody have any questions about that? Now, most of these problems are rigged, but sometimes you have to use your calculator. Let's do one more. This next one's going to be kind of hard. Can I go to the next slide? Yeah? Okay. If I say the log base of 4, or log base 4 of 1 equals something, that means, remember that y equals log base b of x, or b to the y equals x. That's the relationship between x and y. So that means that I have this base of 4 raised to the y should equal 1. How would you get that one? Very good. 0, right? Y would equal 0. Because 4 to the 0 is 1. You guys got that rather quickly. Last year it took them a few minutes to try to figure that out. They were like, 4. Well, there's 4, there's 16. Good, good. All right, can I do another one? Do you guys have that written down? I'll get a second. Well, let me rephrase that question. I didn't say, do you want me to do another one? I said, well, let me rephrase it. Are you done writing this down? Okay, so I'm going to do another one. Got a bunch of hecklers in the crowd today. Now this one, you guys should have the hang of this by now. Oops. Let's have some fun with this though. You ready? I'm going to change it around a little bit. Log base smiley face of smiley face.
No, it has to be a frowny.
A frowny. Oh, did you guys hear about
Tell the difference.
the frowny? Well, it's not a frowny now.
A winky face.
Wait. So I have a winky face. How do you draw a winky face? Like
Well, that looks semicolon.
Oh,
jeez.
that looks a little weird.
Okay.
How about like this?
No, like what?
Winky face, winky face. Alright, so now y equals the log base b of x. So that means that b to the y has to equal x, right? So we've got our base, which is winky face, raised to the y equals winky face. What's y? No. I heard somebody say it. 1, right? Because the only way, this is the base, the only way you can end up with the base is if you raise it to the first power. Right? So I did that on purpose. In your textbook, it had like log base 7. Whoops. I get a little carried away there. Log base 7 of 7 equals 1. Well, what I wanted you to know is no matter what we plug in there, it could be, because sometimes you'll do variables too. So in this case, it would be 1. Right? Because when you take the base of the base, right, it's always going to equal 1, because the base raised to 1 is the base. Does that make sense? All right, any questions on this?